Today we're talking about the difference of squares factoring. So we have a couple of factoring here, and we're just going to do like we normally do and multiply them out. So x and x is x squared. That'd be 4x. And this would be negative 4x. And this would be negative 16. And if you were to look at these two, you'll see that they are the opposite of each other, so they cancel each other out. And you get x squared minus 16. When you take a look at this one, 3x times 3x is 9x squared minus 3x plus 3x minus 1. These again would cancel each other out. You get 9x squared minus 1. So you see how it goes from factoring of two binomials, and you get a binomial answer, and you'll notice that there's 9's a perfect square, x squared is a perfect square, and 1 is a perfect square. So when we were doing these, would you notice about what happened in the middle terms? They canceled each other out. And then you'll notice that one was negative, one was positive, and when you multiplied them, you get a negative. So the last term in the binomial is a negative. And these are going to be clues that's going to help you when it comes time to factoring perfect squares. So compare and contrast the terms in each set of parentheses. We have two positive x's, but we have a plus and we have a minus, and then we have a 4. And so just knowing what we know from up here, x times x is x squared, 4x and minus 4x will cancel each other out, and this is going to be minus 16, because 4 times 4 is 16. Okay? All right, so when you multiply a number times itself, it creates a perfect square. So we know that 2 squared is 4, 11 squared is 121, 12 squared is 144, 136, oh wait, 169, 169, 196, 15 squared is 225, 16 squared is 256. 17 squared is 289. 18 squared is 324. And 19 squared is 361. Knowing your perfect squares is going to be very beneficial when you're working quickly to undo perfect squares. You could always do the square root of a number to find out what the answer would also be. So if I had 361x squared, I could take the square root of each of these. Square root of this would be 19. Square root of x squared would be x. So the perfect square is 19x. Difference of squares formula. If you have a squared minus b squared, when you factor it out, you're going to have 2 a's, so there's your 2 a's, you're going to have 2 b's, and one of them has to be a negative, just one, and it doesn't matter. You could also have written it like this, just as long as one is with subtraction and one is with addition. Okay? All right, so if I have this perfect square of 9, the square root of 9 is 3. Square root of x squared is x. And 4 is a perfect square, and square root of it is 2. So there's 1. and then 3x plus 2 would be the other. When you have them with addition, see how this is with subtraction? With addition, it does not work that way because there is no way to get this to work. This will not factor. So it does not factor. If I were to try it and had s as both, because it's s squared, and then 9 is, square root of 9 is 3, it's positive, so it's either going to be both plus or both negative. And if I were to go ahead and multiply that out, I would have s squared plus 3s plus 3s plus 9, or I would have s squared minus 3s minus 3s plus 9. Depends on if I'm using the positive or negative. But when I look at these don't cancel each other out. This becomes negative 6s plus 9. And this is not the same as this. So that is why when you have with plus and two perfect squares, it will not factor out. Okay? It does not work. When I take a look at the next one, I have 225. And remember when we did our perfect squares, 225, the square root of it is 15. X to the fourth power, well, 4 is a perfect square. Uh, 25 is also a perfect square. Oops. Not 25 again. This will be a 5. And then because it's x squared, each of them will have an x. Okay. All right. If you have any questions, please make sure that you let me know. I will also be attaching a separate video to kind of give you just a different perspective. Thank you.